Welcome to Cryp. This is Aaron Bittman, software developer. Back in the 20th century, I enjoyed solving cryptograms in magazines, like this one. Cryptograms are messages that were encoded with a monoalphabetic substitution cipher. In other words, one letter in the English alphabet would be substituted with another letter or symbol. The message in code is called ciphertext. The plain English to which you translate the encoded message is called plaintext. Of course, solving such problems with only a pencil can sometimes be difficult and tedious. When you guess that a ciphertext symbol represents a certain plaintext letter, you have to search the whole puzzle for all occurrences of that symbol to translate it to the plaintext letter. If you later change your mind, deciding that's not the plaintext letter you want to guess, you have to search the whole puzzle again to erase every occurrence of that plaintext letter you wrote. Obviously, that kind of task screams for a computer program to do the work for you. Furthermore, a computer can quickly search through a dictionary file and suggest to what plaintext words a ciphertext word might translate, based on whatever criteria you decide. So when I learn a new programming language and come up with projects for myself to get practice writing in that language, I often choose to write a program to help me solve cryptograms. I typically name this program Cryp, short for cryptogram. Maybe one day I'll come up with some clever backronym like cipher resolution yada yada program. So for instance, when I was studying Java and swing classes, I wrote a swing version of Cryp. Maybe one day I'll put that version up on GitHub as well. But when I wrote those other versions of Cryp, I did so with one hand tied behind my back. I mean that I didn't look at other people's code to solve cryptograms, although other people certainly did a better job of it than I did. The idea was to force myself to code more so I'd get more practice, but in a way, that's wrong. No one got a prize for reinventing the wheel after the advent of the car. Good programmers don't just think of their own ideas, they learn other people's ideas and make use of them. So when I started learning Python, checking Python books out of public libraries and thoroughly studying them, I had to include Cracking Codes with Python from No Starch Press. I'll admit it, the book had many good ideas. I wish I had thought of them years earlier. But the code in this book had its shortcomings. I will demonstrate. Here's the Python file that the book and website provided. Into this file I typed up some puzzles from a cryptogram magazine that I bought decades ago. Let's look at this first one here. At a glance, you can see that the program correctly deciphered most of it, but the single word with two I's is obviously wrong. They can't both be I's. And the underscores just beg to be solved. How nice it would be to have an interface to fill in those blanks. Let's try a puzzle that's shorter. Shorter puzzles tend to have fewer clues, so they tend to be harder. As you can see, the program could do very little of it. I'll get to this last puzzle here later, but the point is that I want an interface that will let me fill in those blanks, just like the interface I wrote in so many other languages. So let's take this first puzzle that I showed you and copy it to the clipboard. Now, let's look at my program. I hit the populate button, and I'll explain like exclusion later. For now, we won't use that option. But here you can type or paste a puzzle. Here you see that most of the solution is good, but some of the solution is clearly wrong. The I and the Z are both translated to an S. They can't both be S. And of course, there are some unsolved letters. By the way, notice the window gives us a frequency count of all the ciphertext letters, first in alphabetical order, and then in descending order of frequency. That can help us make guesses. Anyway, let's guess that the E is an A. When I type a plain text A over the ciphertext E, you'll see that every E is translated to an A across the puzzle. And so it is for any space. Well, you get the idea. This program makes it very easy. Now, let's try a harder puzzle. With so few letters solved here, oh, by the way, this is a bug. I'll admit I have not yet tracked down this bug, but it's no big deal. Type anything in there and it goes away. Anyway, with so few letters solved, it would be nice to see all the plain text words in a dictionary that match what clues we have. Let's take this word. By putting the focus on any letter in that word, the Solve Word button gives me this interface. Actually, I can search for any ciphertext word with any known plain text using this interface. You can see that all that stuff is editable. In fact, if you don't want to bother typing up the whole puzzle, you can still use this window to tackle individual words. But let's just keep this simple. I hit Solve. There are 5 possible translations in the dictionary. By the way, the dictionary isn't complete. In fact, this dictionary file is very small compared to dictionary files I used in other versions of the program. It excludes many words that aren't very likely to come up in a cryptogram, which helps to narrow it down, but sometimes leaves words out that you might wish were in there. Anyway, we can narrow the answers down by guessing at some of the plain text. We can also narrow it down with this option, like exclusion. Like exclusion means that a letter cannot translate to itself. For instance, a ciphertext H cannot translate to a plain text H. Several people have pointed out to me that there's no rule that like exclusion must apply to a cryptogram. However, I've never seen a professionally published cryptogram that didn't have like exclusion. So, with that option checked, let's hit Solve again. Now, all the possible words, in our dictionary anyway, translate the first letter to an S. So let's assume that it's an S. Close this window and enter that S. Now, let's try this word. There's only one guess. If we click that word and hit the Select Word button, or double-click the word, the puzzle will populate accordingly. Let's do the same for this word. Again, there's only one. Let's select that. These guesses seem reasonable, So let's assume that n is I. In that case, q must be a. So let's try that. Now, let's go back to this last word here. Since we're guessing that F is E, so that eliminates striped and striven, so let's guess stringy. And at this point, you can make some pretty reasonable guesses. Now, going back to the original program, let's look at this last one. Notice that it has an apostrophe. This program doesn't know how to deal with apostrophes because in cryptograms an apostrophe translates to an apostrophe. I find that words with one tend to provide a great clue to help solving a puzzle. So I added the logic for apostrophes to the program and over 70 words with an apostrophe to the dictionary. So here I'm running the book's code and get very little. Now, let's copy the puzzle to the clipboard and paste it into my program. As you can see, a word with an apostrophe can be a tremendous help in the beginning. Now, let's try this word. Prostrate seems unlikely, but let's try it. Now, one word becomes O-S-E, which is obviously wrong, so I'll try frustrate. And, as you can see, the puzzle is now almost done. You get the general idea, but I've only briefly hinted at some of the program's other features here. For instance, you can open windows for multiple words. And compare the results side by side. So feel free to play with the features. And here's a bonus. When I wrote this Python version of Cryp, I also wrote, for the first time in my life, a program to do the reverse. I named it by spelling Cryp backwards and calling it perk. Actually, I was greatly surprised by how easy it was to write and how short it came out. You can see how short it is. So you just get a quote, like this one, run the program, and perk will generate a cryptogram for you. I did this with the idea of creating test cases, although if you know the solution, it might be hard to figure out what guesses the users might make and what the users will intuitively know. But anyway, there it is. So feel free to peruse my code and feel welcome to give me any feedback on GitHub.